Dear second prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new lesson. Today, inshallah, we have Algebra. It's Unit 1, Lesson 2. The lesson is the set of the irrational numbers. In this video, inshallah, we are going to study the second lesson in this term, and we are going to learn what the meaning of the irrational numbers, and we are going to remember the sets of numbers, the sets like natural numbers, integers, and the set of rational numbers. Okay, and we are going to solve many problems about the lesson. Let's start the lesson. First, we have a new concept called the set of irrational numbers. But first, before explaining the meaning of irrational numbers, we need to remember the sets of numbers. The first set we studied before called the set of counting numbers. This set including 1, 2, 3, 4, 5, and so on. Okay, the whole numbers started from 1. And next we are going to study the set of natural numbers, which start with 0, which is 0, 1, 2, 3, 4, and so on. Okay, and then we are going to study the set of integers, which including n besides the negative numbers like this, which is included 0, 1, 2, 3, and so on, and the negative 1, negative 2, negative 3, and so on. Okay, and then we are going to study the set of rational numbers Q. Okay, the set of rational numbers Q was the set of any numbers. Any number can written as a fractional form in which the numerator and the denominator are integers like this. It's written as a over b. A is a numerator which belongs to z, and this must be integer. B is the denominator, and this must be integer, but b not equal to 0, or the denominator doesn't equal 0. And now we are going to take some examples for the rational number like this. 2 over 3. 2 over 3 is a rational number because this is a fraction written as a over b. Okay, 2 is an integer and 3 is an integer, then 2 over 3 is a rational number. Another one, negative 1 over 4, both are integers, then the fraction negative 1 over 4 belongs to Q. Negative 1, which is negative 1 over negative 4 over 1. Okay, this one is a fractional form because we can write it as negative 4 over 1, then negative 4 belongs to Q. And 0, which can written as 0 over 1, also belongs to Q. If we have a root like this, first we need to find the value of the root, which is equal to 2 over 5. 2 over 5 here is whole number over whole number, then 2 over 5 is a rational number. Next, we are going to study the set of irrational number, which denoted by Q dash, which is the main set in this lesson. Okay, the set of irrational numbers is the opposite of the rational number. The rational number is any number written as a fraction, a or a over b, but the set of irrational number is any number can't written as a fractional form. Again, any number can't written as a fractional form. For example, if we have a number like root 5 in the calculator equal the approximated value equal 2.2606 and so on, this number can't written as a fraction. Then root 5 is not a rational number. This is an irrational number, Q dash. Again, if we have cubic root 7 equal 1.9129 and so on, this number can't written as a fraction, then this number, okay, is an irrational number. Next, if we have a fraction like this, root 2 over 5, here we have fraction, but this is not a whole number, this is root. Okay, by finding the value of this root, it's equal 0.6324 and so on. This number can't written as a fractional form in which the numerator and the denominator are integers, then this form is an irrational number. Next, pi. pi, which is the approximated value 3.14 or 22/7. The value of pi approximately equals 3.14159 and so on. We can't find exact value for pi equal written as a fraction. Someone of you asked me, Mister, but pi equal 22/7. Okay, pi equal 22/7 this is an approximated value. Okay, then pi here is an irrational number. Now let's solve some problems about the set of irrational numbers. In this example, show which of them is rational and which of them is an irrational number. Okay, first we have here cubic root 3/3 and 3/8. We can write this number in the calculator like this: shift root and then shift fraction 3 and 3/8. This one equal 3/2. Okay, 3/2 is a fraction. Again, 3/2 is a fractional form. Then this number is an irrational number. Then this number belongs to Q. Okay, the next one. Here we have cubic root 36. Cubic root 36 equals 3.30. I can't write this number as a fraction. Check by using S to D. Okay, like this, it's equal this fraction, then this number is an irrational number. Okay, then I'm going to write belongs to Q dash. Next, square root 9 plus square root 16. This one equals 3 plus this one equal 4. The answer equal 7. 7 written as a fraction, 7/1. Okay, and then this number is a rational number. This number belongs to Q. The next one. Here we have square root 36. Square root 36, which is equal negative 6. Negative 6 belongs to Q. Here we have pi/2. I said before that pi is an irrational number, then pi/2 also an irrational number. This belongs to Q dash. Here root 4 minus root 11. Check by using calculator like this. Root 4 minus root 11. It's equal 2 minus root 11. Check by S to D. It will be like this. This is not a fractional form. Then this number belongs to Q dash. Okay, let's solve the next example. In this example, find the approximated value for each of the following numbers. To the nearest number, first one, root 11 to the nearest hundredth. Okay, first I need to find the value of root 11. Root 11 equal like this: 3.3166. Okay, it's equal 3.1366. Okay, let's remember the approximated value, the approximation. Okay, here the nearest hundredth. Okay, 1 is the tenth, 3 is the hundredth, and 6 is the thousandth. Okay, underline the place value, which is hundredth. Okay, and then look to the next. The next one, 6. 6 here is strong. Let's remember the strong digits. Strong or like this: 5, 6, 7, 8, and 9. The weak digits are 0, 1, 2, 3, and 4. Okay, the strong digit, add 1 to the previous, and weak digit, leave the previous without change. Okay, here we have 3. The next is strong, then we add 1 to 3. Okay, again we add 1 to the 3 here. It will be in the simplest form like this: 3.14, because 3 plus 1 equal 4, and ignore the rest of the number. Okay, the next one, cubic root negative 9 to the nearest tenth. Cubic root negative 9, as we took in the calculator, negative 9 like this, negative 2.0808, and so on. To the nearest tenth. The tenth here is 0. Then by looking to the next one, the next digit 8 is strong. This is 8, this is strong digit 8. We'll add 1 to the 0. It will be like this, approximately, equal negative 2.1, and ignore the rest of the number. Let's solve the next one. Find 2 consecutive integers which the following numbers included between them. Okay, the consecutive integers means integers next to each other. For example, 4, 5, 6, 7, and so on are consecutive integers. Okay, okay, now I need to find 2 integers in which root 5 is included between them. Okay, root 5 here is not an integer. Okay, I need to find 2 integers in which root 5 included between them, but I will not use the calculator. How come? Root 5 square root, this is the second root, as we took before. This is the second root. Okay, the square root, we are going to search in the perfect squares. Again, perfect squares. The perfect squares are 1, which is 1 power 2, and 2 power of 2, 4, 3 power of 2, 9, 4 power of 2, 16, and so on. Okay, search about 5. 5 here included between what and what? 4 here included, 5 here included between 4 and 9. Okay, 4 is the, okay, 4 perfect square means 2 power of 2, and 9 means 3 power of 2. Okay, then I can write like this: square root 5 lie between square root 4 and square root 9. Okay, this is clear. 5 greater than 4 and smaller than 9. Why do I choose root 4 and root 9? Because root 4 equal 2 and root 9 equals 3. Then root 5 is included between 2 and 3. Again, okay, first search about the perfect squares. Why? Because we have square root. If we have cubic root, then we search in the perfect cubes. Okay, the perfect squares 1, 4, 9, and 16. Okay, root 5 here, 5 here included between 4 and 9. Okay, then root 5 included between root 4 and root 9. Root 4, which is 2, root 9, which is 3. If I need to represent this one on the number line, but this is not required, okay, like this, 1, 2, 3, you will find that square root 5 included here in this position. But this operation is not required. Okay, now I'm going to find two consecutive integers included cubic root 20. Okay, cubic root, now we have here cubic root. Okay, as we see here, we have cubic root like this. I'm going to search in the perfect cubes. Again, I'm going to search in the perfect cubes. The perfect cubes: 1 power 3, 1. 2 power of 3, 8. 3 power of 3, 27. And 4 power of 3, 64, and so on. Here I found that 20 included between what and what? It's included between 8 and 27. Okay, then if I need to write the roots of them, I will be write like this: cubic root 20 greater than cubic root what? Cubic root 8 or cubic root 27. I'm going to write the greater one first because we have negative numbers here. Okay, it will be negative 27, and here cubic root negative 8, and this is negative also. Okay, cubic root negative 27, which is negative 3, and then cubic root negative 20, and then cubic root negative 8, which is negative 2. Let's solve the next one. If x is an integer, again, x is an integer. Integer mean whole number. Okay, find the value of x in the following cases. Okay, x here is an integer. I need to find the root 2 greater than x and smaller than x plus 1. It means that root 2 included between two consecutive integers. Okay, here we have square root. Then I'm going to search in the perfect squares. Again, I'm going to search in the perfect squares. The perfect squares are 1 power 2 equals 1, 2 power of 2, 4, 3 power of 2, 9, 4 power of 2, 16, and so on. Okay, 2 here included between what and what? It's included between 1 and 4. Then square root 2 greater than square root 1 and smaller than square root 4. Okay, 1 here, which is 1, root 4 here, which is 2. Then square root 2 greater than 1, smaller than 2. Then the two integers included root 2 between them, 1 and 2. Then x here equal this 1. Okay, then we can write that x equal 1. Okay, the next one. Here we have square root. Then I'm going to search in the perfect squares. The perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, and 81. Don't forget, this is 1 power 2, 2 power 2, 3 power 2, 4 power 2, and so on. Okay, here we have root 80 included between 64 and 81, like this. Then root 80 it's greater than root 64 and smaller than root 81. Then root 80 greater than 8, smaller than 9, then x here is 8. Okay, then I will write x. Don't forget to write x. X here is 8. The next one, cubic root 5. Here I'm going to search in the perfect cubes. Okay, the perfect cubes are 1, 8, 27, and so on. Okay, here we have root 5 included between 1 and 8. Okay, then cubic root 5 greater than cubic root 1 and smaller than cubic root 8. Cubic root 1, which is 1, cubic root 8, which is 2, and this is x, then x equal 1. Okay, the next one, we have here cubic root negative 100. I'm going to search in the perfect cubes. The perfect cubes. 1, 8, 27, 64, 125. Don't forget, this is 1 power 3, 2 power 3, 3 power 3, 4 power 3, and 5 power 3. Okay, here we have 100 included between 64 and 125. Then we are going to write the numbers like this: cubic root negative 100. But don't forget, if we have negative numbers, then we are going to start with the greater number first. I'm going to start with negative 125. It will be cubic root negative 125, and here cubic root 64, negative 64. Okay, here we have negative 5 less than cubic root negative 100 less than cubic root, negative 4. Then the two numbers included root negative 100 are negative 5 and negative 4. Here we have root 5 is the value of x, then x equal negative 5. Okay, let's solve the next one. Complete the following: the side length of square whose area 6. Okay, first I need to remember the square. The square, this is the square. This line is called the side. Okay, the area of square equal side to the power of 2. Okay, but if we need the side length, it's equal square root the area. Okay, again, area equal side power of 2, side equal root the area. Okay, now we need what? The side length of square whose area, this is the area, then I need the side length. Okay, the side length equal square root the area, which is square root 6. Square root 6, okay, has no simplest form more than this, then the side here equals the square root 6. Okay, don't write it as a decimal because we already studied the irrational numbers, which is the roots form. Okay, then we are going to leave root 6 without change as I explained here. Okay, the next one, by using the same rules, the area of square whose side length root 3. Okay, here we have root 3 is the side length. Okay, then we need the area. Okay, here the area equal, as I explained, area equal the area equal side power of 2, which is equals root 3 to the power of 2 equals 3. Okay, then the area equal 3 centimeter square. The square whose area 10. Here we have the area is 10, then the side length equal what? Then we need the side equal square root the area, which is square root 10. Okay, here we don't have simplest form for root 10, then we are going to write root 10 without simplify. Okay, the next one. Calculate the side length and the diagonal length of square whose area 10 centimeter square. Okay, again the square this one is called the side and this one is called the diagonal. Okay, area of square equal side power of 2 or area of square equal half time diagonal power of 2. Okay, if we need to reverse this rule, okay, then the side equal square root the area, and here the diagonal equal square root 2 times the area. Okay, then keep these rules. This is very important. Write it in your notebook. Okay, here we have the area equal 10. To find the diagonals, okay, to find of course the side first, side equal square root area equal square root 10, and the diagonal equal square root 2 times the area equal square root 2 times 10. In the simplest form will equal 2 square root 5 centimeters. Now this is the side and this is the diagonal length. Let's solve the next example. Here we have find in Q dash the solution set of each of the following. Okay, here we have 3 equations like this. Okay, in the first one we have 5 over 4 cubic root x x power 3 equal negative 2. First I'm going to send 5 over 4 there by divide operation, then it will be x power 3 equal negative 8 over 5, and then I'm going to take the cubic root to both sides. Okay, then x equal, when we write this one in the calculator, the calculator give me a decimal like this, shift root and then 8 over 5. It will give me decimal like this. I will write the answer, okay, as a root, not as a decimal number. Okay, I will write it as cubic root negative 8 over 5. This number belongs to Q dash. Then the solution set, don't forget to write it, equal cubic root negative 8 over 5. Okay, the next one, here we have minus 7. I will send it to the other side as plus 7. Okay, then 125 x power of 3 equals 27. I will send 125 there as divide. Okay, then x power 3 equal 27 over 125. I will take the cubic root for both sides to cancel the cubic root, the power 3. Then x equal 3 over 5. This one doesn't belongs to q dash. This number is rational number, then the solution set here equal phi, because the substitution set is in q dash, don't forget. Okay, here we have the third one. First I'm going to send plus 2 there as minus 2, then quarter x power of 2 equals 64. I'm going to send the quarter here divided by quarter, then x power of 2 equal 256. Okay, then I'm going to take the square root for both sides, because we have x power of 2, then x equal negative or positive 16, but 16 doesn't belongs to q dash, then the solution set here is phi. Okay, the next one, drill 8, example 8. Prove that root 2 is included between 1.4 and 1.5. Okay, this one, now we need to prove that root 2 included between 1.4 and 1.5. The first step, I'm going to cancel the root 2. How come? Okay, by squaring the three numbers like this. The first step, I will write 1.4, make it power of 2, and 1.5 power of 2, and square root 2 power of 2. Okay, 1.4 power of 2 equals 1.96, and 1.5 power of 2 equals 2.25, and root 2 power of 2 equal 2. Okay, now I have three numbers. I'm going to write the three numbers in order like this. The smallest number in between them is 1.96, like this. Okay, less than 2, less than 2.25. Okay, then the first step, make the three numbers to the power of 2 and then arrange them in ascending or descending, it's up to you. And then I'm going to take the square root, okay, back to its original form, root 2, like this. I will take root square root to 1.96 and square root to 2 and square root to 2.25. Okay, the first one, square root 1.96 equal 1.4, and here we have square root 2, and here we have square root 2.25 equals 1.5. Then this is the proof in order, therefore square root 2 greater than 1.4 and smaller than 1.5. Let's solve the next one. Here we have cubic root to prove that this one included between the two numbers 1.2 and 1.3. Okay. Here to cancel the cubic root, I'm going to raise this number to the power of 3. Okay, this one to the power of 3, and this one to the power of 3, and this one to the power of 3. Cubic root 2 to the power of 3 equal 2, and 1.2 to the power of 3 equal 1.728, and this one to the power of 3 equal 2.197. Okay. Now I'm going to arrange the three numbers. The least one is 1.7. It will be 1.7 to 8 less than 2 less than 2.197. Okay, and then I'm going to take the cubic root for the three numbers like this. Therefore, 1.2 less than cubic root 2 less than 1.3 as he asked to prove. The next one, prove that cubic root negative 17 included between those two numbers. Okay, now I'm going to raise the three numbers to the power of 3. This one to the power of 3 equal negative 17, and this one to the power of 3 equal negative 17.576, and this one to the power of 3 equals negative 15.625. Okay, the next step, I'm going to arrange them. The smallest number is this one, negative 17.5. Less than this one, the next one, and less than negative 15.625. If you can't arrange them, you can number them. The first one, the smallest number is 1, this one is the first, and this one is the second, and this one is the third. Okay, now I'm going to take the cubic root, because I have here cubic root for the three numbers like this, cubic root for the first, cubic root the second, cubic root the third. Okay, the first one equal negative 2.6. This is cubic root negative 17, and this is cubic root, and this is negative 2.5. Okay, therefore cubic root negative 17 between negative 2.6 and the negative 2.5. Okay, let's solve the next one. Okay, now if he asks me represent any root on the number line. Okay, for example, if we have example like this, determine the point that represent root 3 on the number line. I do what? I need to draw right angle triangle in which its side equal root x and the hypotenuse equal x plus 1 over 2 and the other side equal x minus 1 over 2. Again, the side length of the square of the triangle root x and the other side x minus 1 over 2 and the hypotenuse x plus 1 over 2, and then I'm going to represent. How come? Let's solve the next one. Here we have, I need to represent root 3 on the number line. I'm going to draw triangle like this, right angle triangle. The side here equals root 3. The hypotenuse equal 3 plus 1 over 2. 3 plus 1 over 2 equal 2. Then the hypotenuse equal 2. And this side equal 3 minus 1 over 2 equals 1. This side equal 1. Okay. Now to represent root 3 on the number line, then I'm going to draw right angle triangle like this. The hypotenuse equal 2 and the side length equal 1. Let's represent this in the number line like this. Okay, the first step, I'm going to draw the number line like this. 0, 1, 2, 3, 4, 5 and so on. To the left, negative 1, negative 2, negative 3 and so on. Okay, of course I will represent on the graph paper. Okay, and I will draw the y-axis like this. Okay, 0, 1, 2, 3, 4 and so on. Okay, this is the first step. As I said before, I'm going to draw triangle. Its height equal 1 and its hypotenuse equal 2. How come? I will like this. I will bring the compass like this, okay, and I will, okay, measure. I will open the compass 2 units, measure it here, okay. The measure of the compass exactly as the measure of the hypotenuse. Okay, I will stand here at 1 because this is the height of the triangle, and then I'm going to turn the hypotenuse like this to draw an arc like this. This arc, this distance equal 2 units. Okay, here we have like this triangle. Its height equal 1. Its hypotenuse equal 2. Its base equal root 3. Then this is the position of root 3. Let's solve another one. Now I need to represent root 7 on the number line. Then I need to draw, as I said before, I need to draw right angled triangle like this. Its base equal root 7. Its hypotenuse equal 7 plus 1 over 2, which is 4. Its hypotenuse equal 4. And its height equal 7 minus 1 over 2 equal 3 equal 3. Then the height equal 3. Okay, height equal 3, the hypotenuse equal 4, and the base equal root 7 centimeters. Okay, let's solve this one. Okay, now I need to draw triangle. Okay, its height equal 3 and its hypotenuse equal 4. How come? First I will open the compass like the hypotenuse 4 units like this. I will open the compass 4 units like this. Okay, and then I will put the sharpener here at 3. Okay, to draw 3 units like this. I will stand over 3 like this. Okay, and I will turn this one like this. Okay, This is the position okay, this is the position of square root 7. I will draw the triangle like this. Now I have, as I explained before, I have triangle, its height equals 3 and its hypotenuse equal 4 and its base equal square root 7. Okay, as I explained, then this is the position of square root 7. Okay, let's solve another one. Now I need to represent 1 plus root 7. Of course, I need to represent, okay, to find root 7 first before finding 1. How come? I'm going to draw triangle, right angle triangle like this. Its base equal root 7. Its hypotenuse equal 7 plus 1 over 2, which is 4. Its height equal 7 minus 1 over 2, which is 3. I need to represent this triangle, okay, but I will mention, or I will stand by the compass after 1, okay, after 1, because I have here 1 plus root 7. Let's represent this one on the number line like this. Now I need to represent 1 plus square root 7. I will follow the steps of drawing root 7, but when I drawn root 7, I started as I represent the heights at 0. But here I'm going to make the height over 1 like this. How come? First, I'm going to open the compass 4 units. Like this, from 1 to 4. Okay, and then I will draw the height from 1, not from 0. Okay, before I drawn the height from 0, but now I'm going to start after 1 because I have 1 plus square root 7. Okay, and now I'm going to to stand with the compass here like this, and I will draw like this a curve like this. This distance from 1 to 3 point whatever 6, okay, this one represent root 7 and this one represent 1, then finally it will be 1 plus root 7. Okay, now like this I will connect between this one and this one. Now I have here this one, this distance equal 1 and this distance equal square root 7. Then finally the distance equal 1 plus square root 7, and then this is the position of 1 plus square root 7. Okay, now let's solve the next one. Now I need to represent negative root 5 on the number line. Okay, first if I have root 5, I will draw right angled triangle like this. Its base equal root 5, its hypotenuse equal 5 plus 1 over 2, which is equal 3, and its height equals 5 minus 1 over 2, which is equal 2. this one equals 2. Okay, now I need to draw a triangle. Its height equal 1. Okay, its hypotenuse equal 3. Again, its hypotenuse equal 3. Okay, let's see the representation on the number line. Now I need to represent root 5. As I said before, I will write right angle triangle, its height equal 2 and its hypotenuse equal 3. But now I need to represent negative root 5. It will be from the left side in the negative direction. And now I will stand at 0 to draw the height, which is 2. And then I will open the compass 3 units like this. Like this. I will stand at 2 and draw an arc here in this way. Okay, and then I will connect between 2 and this point. Now I have right angled triangle. This right angled triangle, okay, its height equal 2, its hypotenuse equals 3, and its base equals root 5. But here in the left direction, in the negative direction, it will be negative 5. Then this point is the representation of root 5. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.